So guys, let's quickly move on to a plumbing system. So now first question arises that what is a plumbing system and why is it used and why is it so important in a building. So a plumbing system is a complete network of pipes, valves, fixtures, tanks, pumps and fittings which is designed to manage how a water enters, how a water leaves and how it is circulated in a particular building. So it forms an essential part of a residential, commercial and industrial structure of a building. So now we have three sort of types or systems used in our plumbing. We have our sanitary drainage system, which is also known as wastewater removal system. We have our potable water system, which is also known as freshwater system or water supply, and we have a stormwater drainage system, which is also known as stormwater management system. So now let us start with a potable water system or freshwater system. In this particular freshwater system, the water is delivered clean, it is delivered pressurized, and it is used for daily uses such as drinking, cooking, bath water, washing, and firefighting, etc. etc. So this is our basic water that we drink and we get in our taps and closets, right? And now the second type of water we have is our sanitary drainage, or which is also known as wastewater. So this particular water is unsanitary water, which we get from our water closets, we get from our toilets, we get from our unsanitary drains, etc. etc. So this wastewater is collected and carried away into sewage and using sewage pipes. And this water system is very important in order to prevent the health hazards, because this water is unsanitary in nature. And then we have a next system called stormwater drainage system, or also stormwater management system. It is used for handling rainwater and preventing floods, waterlogging and structural damage. Can you see here on our roof we may get some rain and we may get some runoff from this particular roof. So this stormwater system manages all these particular water that we get from our roofs, and then it prevents flooding and waterlogging, and it safely sort of transmits this water into stormwater drainage. So in this particular picture, if I zoom into this particular picture, this is a typical layout of a house and how these particular system interact with each other and how these system work. So if I zoom in into this particular layout, can you see here we have different sort of pipes here. So let's first talk about the freshwater pipes or water supply. We get our fresh water supply from our water mains, which is provided into a city, and then we may have some valves here, and then this fresh water system is delivered cold, it is delivered pressurized, and it is delivered clean. So it gets traveled, and some closets or in some fixtures we may want some cold water, and then this gets directly delivered to these fixtures. And also we have a water heater here. We may want to heat up this water, and then it gets really delivered into those particular fixtures. The next thing we have is our stormwater drainage system. Can we see here the city provides a stormwater drain. This stormwater drain carries all the drain water, all the sort of storm water which is collected from the pavements and from the roofs, etc. etc. using this stormwater drainage system. In this particular stormwater drainage system, we have our rain gutters, and these gets transmitted directly into our perimeter drains, and then these perimeter drains gets transmitted to our stormwater drain using particular sort of pipes. And then the next system we have is our sanitary water system. Can you see here we have a water closet here. This particular water closet, now the waste from this particular water closet gets transferred using these particular pipes. So in this particular example, can you see we have three sort of pipes or DWV pipes. Drain, we have drain pipes. For example, if we have a shower here, that shower the water that drains from the shower is known as that gets transmitted into a drain pipe. We have a wastewater pipe from this particular water closet or toilet, and then we have a vent pipe here. Can you see here this particular sort of pipe goes in this particular direction, and then a drain pipe comes from this particular closet, this particular fixture or closet, and then they both get transmitted down into this sanitary sewer. And then we have another stub up here from this particular pipe, and this particular pipe is known as a vent pipe. So we have three sort of pipes: we have drain pipe from this closet, we have sort of a drain pipe or a wastewater pipe from this toilet, and then we have vent pipe in order to remove all the gases, harmful gases, etc., etc. And then all the effluents from these particular closets, water closets, gets transmitted into our sanitary system. We have a clean out here in case we have to clean out and there may be some blockage, and then these gets transmitted into our sanitary sewer system, which is provided by our locality. So it is an intermix of different sort of pipes used for different sort of uses for our fresh water, for our stormwater drainage, and for our wastewater. So it is an interplay between them. So for our freshwater pipes or potable water, the system is a little bit simple to design in BIM because we only deal with one sort of pipes. Similar thing happens with our rainwater, so for our storm water, but for our sanitary water we have three pipes that need to intermix with each other. They are not three structurally different pipes, but they have different uses. We have a drain water, we have a sanitary water, and then we have a vent. So the material of these particular pipes is same, but the uses are different. So I'm going to be explaining this in the upcoming parts of this particular masterclass. So the next thing we have is our plumbing parts and fittings. We have the different symbols for this. We have different sort of plumbing fixtures, and then we have different sort of plumbing symbols, which you guys need to understand in order to understand the drawings. We have our plumbing fixtures here. We have our showers, we have our sort of showers, etc. We have water closets, we have our drains, etc., etc. So this is all the general things we see in our typical bathroom. Now the next thing is we have our plumbing parts and fittings with symbols. So this is very important, guys. Let's take a closer look at this. So in our plumbing parts and symbols, we have to take care of two important things. First of all, we always use radial elbows here or radial parts. Can you see, always we have some sort of a curve here, so some sort of a radius here. So we never used our metered elbows and metered teeth, etc., etc., just like we used in our HVAC systems. We always use our radial systems here. The next thing we have is, for our wastewater system, we always use a sanitary tree here instead of these straight trees or reducing trees. Why is that? Because sanitary system works on gravity. It is not a pressurized system, so we have to always use a particular sort of fitting which has been designed for our sanitary system. So so the sort of a prefix we always use here is sanitary tree. So can you see we have a straight tree here as well. This is the symbol of 2D symbol of this straight tree. We use this particular system in our in our stormwater drainage systems, or for our freshwater systems or our potable water systems which are pressurized. So the reducing tree, also we use this particular tree for our potable systems. This sometimes is also used in our sanitary systems, but mainly we use our sanitary tree here. We can have a sanitary tree in a reducing form. This means that if this end and this end is 10 inches in diameter, this end may be of 8 inches, or it may be reducing in nature. And then the next thing we have is a P-trap. So this is very important thing, guys. You may have seen in your water closets or in your drains. So this is used in order to prevent all the gases we may get from our pipes or our sewer systems to directly get released into our homes. So we may have some sort of a water level here, so that water level prevents those gases from escaping through this route into our homes or our bathrooms, right? So we're going to be learning a little bit more deeply about this particular P-tap. So this is very important thing that we use our sanitary system, and it's very extensively used in our sanitary systems. We have gate valves in order to shed the water flow or the sort of flow in our freshwater systems. We have a shower head for our showers. We have our lavatory sinks we have our bathtubs, we have our shower stalls, etc., etc. So these particular things, in order to read those drawings, the shower stall will be denoted in this particular 2D symbol, bathtubs will be denoted in this particular symbol, lavatories will be denoted in this symbol, shower head, similarly a gate valve will be denoted in this particular symbol, P trap, we have sanitary tree, reducing tree, street tree, etc., elbow, etc., etc. Now the next thing that we have is our plumbing symbols. If I zoom into this here, for in order to read a particular drawing that is given to us by a design engineer, so he will be referring to these particular symbols here. For our cold water supply symbol, we have a long dash and then a short dash, long dash, short dash, long dash, short dash. So wherever you will see this particular line, so this will denote a plumbing line uh, of cold water supply type, right? Then for hot water supply, we have a long dash and two short dashes, then long dash, then two short dashes, and this will denote our hot water supply. For our drain pipe, we will be getting a sort of a bold line here, which goes all the way, and then for our vent pipe, it is short dashes only. Next things what we have is our coupling systems, sort of coupling symbols here. For the coupling is nothing but it is used to connect the pipes of a same diameter. We have a host hib here, we have a T facing up, so this is sort of a top view of a T. We have a clean out in order to clean our drainage systems. We have our valves, we have our elbows facing up, we have our caps, we have water heaters, we have a 45-degree elbows, we have our showers, bathrooms, sinks, etc., toilets, vents, Y fittings, waste tees, etc., etc. So this is the sanity that we all earlier studied, right? So let me show you how they look like. So guys, this is our sort of a freshwater or potable water fittings here. We have a reducer, coupler, valves, RT, etc., etc. We have connection pipes, we have bends, we have plugs, we have sort of double union ball valves, clamps, flanges, etc., etc. And for our sanitary water, let me show you guys sanitary water. So this is our wastewater sort of fittings here. We have a Y cross, elbows, etc. All of them are sort of a radial here, 90-degree elbows. We have a P trap here. We have different sort of S traps, other sort of traps. We have a T here. We have a coupling here. We have equal tree here, etc., etc. We have different sort of this is the vent pipe plug, and then we have some expansion joints. We have some coupling joints here. We have some floor leakage, etc. Head clamps, etc., etc. So you guys can go through all of them. Now the next thing that we have is a piping sort of plumbing pipe material schedule. So here we have different sort of pipes. We use different sort of pipes in our plumbing. So the general rule of thumb is for our underground pipes, whatever pipes they are, we use our PVC. So we have two types of schedules here: schedule 40 PVC, and other schedule that's not mentioned here is schedule 50 PVC. So for our drain water pipes or our storm water pipes, we always use PVC pipes. Why we use PVC pipes? In order to prevent rusting, because below the ground we have a water penetration, we have a moisture. So in order to prevent them from corrosion, we use our PVC pipes here. And then above ground, for our sanitary systems, we use our cast iron pipes. Can you see here? Above soil or ground, for wastewater, vent or rainwater pipes, or for stormwater drainage, we use our cast iron solid pipes and fittings, service weights, etc., no hub joints, etc., etc., right? For our below ground soil, waste vent or rainwater leader, etc., we use our schedule 40 PVC. For below ground soil, waste vent, and for the manufacturer model is given here as well, we use our schedule 50 PVC here. And then for our pressured pipes, which is our freshwater pipes or potable water pipes, we use copper pipes. Can you see here? We have different sort of types of copper here. We have type M copper, we have type K copper, we have type L copper, and we have type L copper tube with routes, etc., etc. Also for our electrical conduits, we also use PVC below the ground, but that's a discussion for some other day. And then here we can see how these sort of pipes look like. We have a void plastic PVC pipe here. Can you see this sort of pipe looks like this, and then we have an elbow for this as well. We have a copper water supply pipe. These are pressured pipes. This is the elbow for this. We have a galvanized iron supply pipes, and then we have our ABS pipes, and then we have cast iron pipes here as well, right? The next thing is drain waste or vent pipe, DWV system. So this DWV system is nothing but a system that is used in our sanitary wastes or sanitary systems. So the drain waste vent system, also known as a sanitary system, is all of the plumbing in your house minus the water supply pipe system, right? So everything is except the pressured pipes is our DWV system. So this includes drain pipes, drains and vents. Drain pipes, drains and vents. When wastewater enters the drain system, it has to flow past a drain trap, that is a U or P shaped piece of pipe that creates water seal to prevent severe gases from entering the home. So can you see here, we have a P trap here. Can you see, we have a P trap? So this is sort of a P trap here, and then we have a P trap here as well. So it says that in order to prevent all the different in order to create a water seal to prevent the severe gases from entering our home, we use a P-shaped or a U-shaped trap here. And every drain, for instance, floor drain, shower drain, etc., require a P-trap connection, right? So I've shown you guys in this particular example. Let's go through this particular example now. So we have our sort of a sink or a lavatory here. It has a P-trap introduced to it, and then we have a water closet here, and then it also has a P-trap which is included inside the water closet itself. And then the drain water which goes and comes out of this particular lavatory goes in this particular P-trap, creates a seal here, and then gets transferred through this particular pipe, goes down and then goes down again, and then goes to the drain pipe and ultimately to the drain water system. And then from this particular lavatory or water closet, the water creates a seal here using this P-trap, and then it also comes out and then goes ultimately into the drain water system. And then we have a clean out. In order we get a blockage here, we can use this particular clean out to clear that particular droppage. So now this particular sort of a branch which comes out of this particular water closet, it is connected using a sanitary tree here. Can you see, it is a tree with sort of a radius pointing down. You see, this is the upward stub up, and then the branch sort of gets curved into this sort of a stub up, right? So we use a sanitary tree here. And then we have a large sweep here. What is this large sweep? It is basically an elbow with sort of a large radius. And then so our water comes in contact with these particular pipes, and they are labeled below. They are labeled sort of in blue color. So but these water never gets in contact with these particular pipes. So now why are these pipes here? So these pipes are all called vent pipes, and these pipes remove all the harmful gases and sort of the nuisance that is created in our sanitary system, and then it sort of transmits it through the roof and outside of our home, so that our home doesn't get all the bad nuisance and smells. So these particular pipes are known as vent pipes. We have a stack here, and then we have a right angle L here, okay, sort of an elbow here, and then water never comes in contact with these particular pipes, right? And now we have our pipe fittings for our DWV systems. We have a short sweeps. You see, we have DWV no hub fittings here as well. We have different sort of pipe lumps, etc. We'll look at this later. And now this is all about vent pipe. When we use our vent pipe, so vent pipe is always used. Can we see here, this is not a pressured system, it always works on the principle of gravity. So our vent should always be facing up, or should be at a minimum angle of 45 degrees. So our vent won't work if we have it at a 0 degree angle here. Can you see, we have an angle of 0 degree here, we have an angle of 45 degree, and we have an angle of 90 degree here. So it only works if it is pointing up or at a minimum angle of 45 degree, because sometimes what happens is due to a surge in pressure, or due to a surge in the water that is available in these particular pipes, sometimes these pipes get filled up to the top. So it won't work, because it will get overflown in this particular vent pipe as well. So a vent pipe is never meant to carry the water or this sanitary water in itself, right? We have a strain water drainage system here, and you see here we have a scupper here, we have some roof drain systems. I think you guys can go all through all this. This is just our stormwater drainage systems. The stormwater drainage system, a storm sewer surface water drainage is infrastructure designed to drain excess rain and groundwater from impervious surfaces such as our paved streets, cars, parking lots, footpaths, sidewalks, and our roofs. The stormwater drainage system is given a slope of 1:8 feet, right? we have a we have a slope of 1:8 feet. So I think I have mentioned slope. Did I mention the slope of this particular DWV system? So for our DWV systems, we have a slope, general slope of 1:4. 1/4 inches. So for a distance of 1 feet in the vertical in the horizontal direction, the slope should be 1/4 inches, right? Let me show if I have some. So if this is sorry let's do it here. If this is 1 feet, one if this is 1 feet, and then the slope here should be 1/4 inches. So this particular slope should be 1/4 inches, right? So if we if we have a wastewater pipe here like this, so it will have a slope of 1/4 inches, right? Now we have some of the riser diagrams. So this is very important, guys. This is the main crux of our BIM modeling for our plumbing systems. We'll be learning how to read these particular drawings in detail in the next session. And then we have some of the cross sections here, and then we have our legends and symbols. So make sure, guys, you go through all the legends and symbols here. And now I'll be showing you the symbols in our project here as well. So this was it, and let's now move on to the modeling. So guys, this is the menu I'm greeted with upon opening the Revit. So if I want to create a separate template for my plumbing, so what I can do here is go to the menu, new tab here, and then I can select the template from here. But all these templates will be in meters and mm, so but I want in feet and inches. So what I can do is I can browse here, and then I can go to the preview here. So I'll have two options here, English and English Imperial. English means meters and mm, and English Imperial means feet and inches. So I'll simply click on this English Imperial, and then we have different sort of templates according to the system tabs here. So I have mechanical, I have plumbing, I have default, which is the architectural, and then we have some construction templates here as well. We have some residential, etc, etc. So for now I'll be using the plumbing default template here of English Imperial type. So I'll click open now. I click OK here again. So now this is the layout of the template, and this is the workspace I get using the mechanical template in my architecture, in my feet and inches. So now if I go to the systems tab here, can you see we have our tabs here? We have this ribbon. I'll simply double click on it in order to expand and contract this ribbon. I'll simply double click on it. Can you see if I double click on it, it gets sort of expanded. Now it gets expanded. So I'll have different tabs: architecture, structure, steel, precast systems, and insert or annotate, etc, etc. So for my plumbing, what I can do is I can go to the systems tab. I have different sort of MEP unit, MEP systems here. We have HVAC system, we have fabrication, we have mechanical, we have plumbing, and we have electrical here as well. So for this particular video, this is a plumbing masterclass, and then we're going to be focusing on plumbing and piping. So we have a plumbing pipe here, we have a pipe placeholder, we have a pipe fittings here, we have pipe accessories here as well, we have pipe fittings here, we have some flexible pipes just like flexible ducts here, we have a plumbing equipments here, we have plumbing fixtures which are our water closets, etc. Can you see sinks, water closets, drains, and showers, etc, etc. We have a sprinkler system. This doesn't come in our plumbing system itself, but we use this plumbing and piping for our firefighting as well. We have electrical here as well. So if I click on this pipe here, we have seen this pipe in our mechanical hydraulic systems here as well. If I click on this pipe in my properties palette, a pipe gets selected. I can select different sort of pipes. We have PVC pipes, we have a standard pipe, etc, etc. Let's keep it at standard for now. And then can you see in the mechanical template we have system types. This is the type of pipe we're going to be using in our plumbing. So in our plumbing system we have different sort of pipes. If I click on it, The top two are the pressure pipes. These are the potable water pipes. We have our domestic cold water, we have domestic hot water, and then third thing we should have here is the reclaimed water. And then we have fire protection pipes here. We have fire protection dye, we have fire protection pre-action, fire protection white, etc., etc. And then we have a hydronic piping. These are our mechanical HVAC systems. And then we have our sanitary pipes and our vent pipes for our wastewater. So now let us first of all create a reclaimed water system here, because that system needs to be included in our pressure pipes. So the first thing that we're going to be first system that we're going to be studying out of the three systems, we have three systems, remember. We have our potable water system or fresh water system, we have our sanitary system or our drainage system, and then we have stormwater drainage system or our stormwater management system. So first we're going to be studying the pressure pipes or the fresh water system or the potable water system. So now let's create this additional system here. So we've already seen this in our mechanical as well. So I'll simply go to the families, I'll simply go to the pipings here. Can I see some pipings, plumbing fixtures, piping systems here? I can see the piping systems and I can see all the systems here. If you guys are not able to see this, you can simply go right click on this and click search, and I'll select piping systems, PIPING SYSTEMS, and then next. Can you see the piping systems have now been selected here? I'll simply close this, and then all the systems that I have for my piping are visible here. Can you see all these systems? I can see if I draw a pipe, and then I can see all of these systems here as well. So now I want to create a new system. I'll simply go here, I'll simply duplicate it, and then I'll rename it as my reclaimed water, RECLAIMED. As you see, I've created a different system here, and now what I can do is domestic. I have to add. Simply go here and rename it. Domestic. I've added here domestic reclaimed water. Right? This looks okay. And then what I can do is I can double click on it to bring out my graphics overrides, and I can edit this and give a sort of a color. I want it in, let us say I want it in this sort of dark blue color, or reclaimed water, let's say it as green. Okay, I'll simply change the opacity here, make it a little bit more darker, and okay it again. If I want to change the pattern of this line here, I can change the patterns here as well. We have different sort of patterns, dash patterns, dash patterns, etc., etc. I'll click OK here, I'll click OK here as well. And now if I want to create a pipe here, I'll create a pipe, and I'm able to change the system here. Can you see, to domestic reclaimed water? If I want, I can simply draw it, and then the pattern that I've selected, I can view it here. But why I'm not able to do this, because view this in sort of 3D, because I have to select fine here. Now I'm able to see it in 3D in the color that I've given it in the graphics overrides. Now this is very similar to our ductwork. I can simply draw a freehand sort of drawing if I want. If I want to create a bend here, I'll simply move the cursor down and then create a bend here as well. If I want to create a stub up, I can simply change the middle elevation to 12 feet and then apply it again and apply it again. Can you see I've created a stub up here? So by this you can create a free drawing just like we created a duct. Can you see here, if I wanted to create a duct, I'll just simply select the duct and then create this particular duct like this. So it is not a mechanical damage, so that's particular is not visible. Simply delete it for now. Now can you see here we have a elbow here. If I want to change this elbow to a particularly different elbow, I'll simply go here and go to the system tabs first and then select the pipe. And now okay, I can go to the edit tab, and then can you see here an option called routing preference? I can simply edit these routing preferences. If I want to select a minimum size and the maximum size that comes, I can select this particular size here as well. These particular sizes will be visible in this particular pipe place. Can you see here we have diameter. I want the minimum size here is 1/4 inches, the maximum is 12. Can you see if I want to change this, I can simply go here and change the minimum size and the maximum size here as well. If I want to change the elbow, I can simply change it to bend, schedule bend, etc., etc. I can change it to any of the elbows that have the families that have been already introduced in my template. If I want to prefer junctions, I can change the preferred junctions here as well. I can prefer to change crosses, etc., flanges, caps. If I want to change the claps, as I can change the claps here as well. And these sort of settings will be saved in my routing preferences. Okay. So this was all about my pipes. But now what happens is, these are the generic pipes that Revit itself gives me. If I want to introduce a family, I can simply introduce a family here as well. But I do not want this generic family. So what happens is, I want to create, I'll simply escape it. Change the VR visibility range. I'll give it, let's say 15 feet. Okay, so my okay, no pipe is visible. So what happens is, I want to create a fabrication part or a fabrication pipe. So how do I do this? Let's move into this now. So guys, now the question arises, why are we going to be using these particular fabrication parts instead of these generic families? So if I click on this elbow here, can you see here, if I go here, we have a standard elbow. So if we have to go into the market and look for this elbow, we're not even sure that this elbow will be particularly available and it will have the same radius and all the fittings that we have done according to this generic family. So we're not even sure that this thing will be available in the market. So that is why we use a sort of fabrication parts here. So fabrication parts, all the fabrication part, if I click on it, can you see a new sort of palette here? I'll simply close my properties browser for now. I'll go and I'll pin it on the side. I'm not able to pin it. What happened? Okay, I'm not able to pin it. Yeah, so I'll move it a little bit towards the side. Can you see we have a new sort of palette called MEB fabrication, but nothing is available here. So you have to go to a particular company and ask them for the fabrication parts and load them into a particular template. So let's open a new template here. Now I can simply go to the file here. I'll go to new. I'll go to sort of, do I have some template here? Oh, I'll have to open this. Let us say. So I'll simply close this file and then go to new here and then browse the template from here. Go to desktop, I'll go to downloads. I have this template here. No, I do not. So I'll just let it upgrade from 22 to 23. Can you see guys, now this template has been loaded. I'll simply go to systems and I have a fabrication part here. I'll select this part. Can you see? Now I am able to see these services here. Simply expand it, and now the company that have the families that have uploaded into this particular template is from the company Nibco. So all of these elements is guaranteed to be present in the market. If we go into the market and ask for this, we'll be able to find this in order to use in our project here. So if I select this particular pipe here, can you see I'm not able to freehand draw this. I am able to only place it, and not even that, if I go to the product entry here, I have a few range of the sizes available that this company actually produces. So if I want to model a pipe here called of let us say 1 by 4 inches, I'm not able to find that particular diameter of this particular pipe here, because this company doesn't produce that particular pipe. So we have to use the pipes and the size of the pipes that are available to us from this particular pipe. So if I want, I can place it here, and this has a fixed length as well, because this company produces these particular pipes in this particular lengths only, not only on the diameters but in the lengths only as well. If I place this particular pipe, can you see it has now been placed? Similar thing is with the elbows. If I select this elbow, can you see if I zoom in, I'm able to sort of place this elbow anywhere. But if I escape now, if I select this particular elbow, if I go in the market and look for this particular elbow, Mueller number WE 500 elbow 90C, I will be surely able to find this particular elbow in the market. So using the fabrication part, we guarantee that all the things that we have actually modeled, the sizes of these particular particular elements that we model, for example these plumbing pipes or these elbows or these reducer or these couplers or these T's, etc., etc., they will be actually available in the market in these particular sizes and in these particular lengths that we model. Now guys, the other thing is, if I select this pipe and if I place this particular pipe and I can edit the dimension of this particular pipe, let's say I want let's say 5-inch pipe, I'll able to I want it I place this pipe. Can you see it has a length here, it has a standard length here of 20 feet, right? So that means that this company doesn't actually sell any of the pipes which are larger than 20 feet. So but now in some projects I want a 30 feet length of the pipe. So what can I do here? I'll simply select this pipe and I'll go here, I'll change the length here to 30 feet. But you sir, you just said that this company doesn't sell a 30 feet pipe, so how will we be able to find this particular pipe? So what you can do is simply click on this pipe, and then can you see an option here called optimize lengths? So it will cut this 30 feet section into two parts. One will be 30, one will be 20, which is the standard, and then other will be of 10 feet, right? 9 feet 11 inches, and this will be in 20 feet. So I've created this 30 feet run in two sections. So now let us say I want to create a longer pipe. As I can simply do is I can simply clip the ends of this particular pipe with the next one, and it will give me a coupler here. Or I can simply go here and select 40 feet and click apply, and then I'll be able to get a 40 feet pipe. Let us say I want a 90 feet pipe, really big pipe, right? I'll apply it. Can you see I'm getting a 90-inch pipe? I don't have to go back and forth and add these particular pipes here again like this. I won't have to add this again as well. So what I can do, escape it, I'll simply click it and use the optimize lengths here. So guys, the next thing is, did you notice we're not able to freehand these pipes? If I go to the pipe here, can you see I'm able to freehand the drawing of these pipes. If I want to move it in this way, I want to move it in this way, I can move it this generic pipe, but I'm not able to do it for the fabrication parts. Why? Because we get a family for this pipe. We don't actually create this pipe, we simply install this pipe in our Revit model. So now I want a bend here. How do I get the bend? I can simply go this bend and sort of go near to this to the end where I want this bend, and if I move near, can you see it automatically gets attached? But I don't want in this particular orientation. What I can do, I can press space. Can you see it is moving up? Can you see? Or down, right? Want to place it in the orientation, I can place it. Now I want the pipe again. I'll change it to okay. I'll change it to standard. Like, can you see it is in horizontal orientation. If I move close to this end, it automatically gets moved to the vertical orientation. I want a T here. Let us say I want this particular T here. I can simply go here. Now what I want is I don't want this particular end it's selected in this particular end. So what I can do is I can simply press space. It will get if I want it up or down, it will get changed in any of the particular orientation. But I don't want this end to be selected. Can you see it's only selecting the left hand end of this particular orientation? I don't want it select to this end. How can I do that? Can you see here an option called up arrow toggle connector? So if I press space, it will rotate, and if I press up arrow, it will toggle connect the different ends of this particular particular T. So if I press the space button, the up key, can you see here? Now I'm able to change if I want this one, or this one, or okay. So I'm not able to do this. Why I'm not able to do this? Can you see? We have an option here called insert part. So I have to turn off this insert part and I have to enable this smart snapping. Now if I click up button, can you see my cursor moves to the other end of this particular elbow of this particular T. I'll press the up arrow again. It has to change to the middle one and then to the right one. So now if I move it closer to this, it will get attached. Now can you see guys, if I select this, we have an option here called insert part. Why is this an insert part option here? Because sometimes I don't want to cut this pipe and then insert this particular T into this. If I want to insert this particular T into this particular pipe here, so I don't have to cut this part. I can simply place it into this orientation. If I want to change the orientation, I'll press escape and then place it here. Can you see? And if I turn off this insert part now, can you see I'm not able to insert this T into this pipe now. Simply what I have to do is I'll SL it. SL means slice it, and then I have to do this. I'll have to move it around, and then I have to toggle this, and then I have to turn off this insert part, and then I have to place it here, and then I have to align it, and then move it to close, and then this takes a lot of time. So we can simply go here and click on this insert part, and then directly insert this particular part wherever we want, right? Now the next thing is our services. All that we have selected right now is from the, can you see in the let me remind you guys, in our pipes, if I click on this pipe, can you see we have a different services here, different system types. We have a sanitary. We created just now we created a different system called domestic water return. That was a different template, that is why it is not visible here. So I want to what I want is, can you see here called service. So we have different sort of systems here as well. We have our plumbing domestic cold water above ground. We have our domestic cold water below ground. Since these are the plumbing pipes, all of them will be, if I select this, it will already be in the copper. But if I select, let us say if I select sanitary water systems, can you see sanitary water systems below ground, above ground? For above ground, if I select this sanitary water system above ground, can you see we get a PVC fitting here, we get a sort of a cast iron fitting here. But now if I go to the below ground, can you see we get a PVC fitting here, right? Pallet is PVC, and for this above ground it is cast iron, and for my vents it is also cast iron here, and then for my above ground pressure pipes it is copper, and for my below ground as well it is copper again. Can you see it is copper throughout? And then we have our drain pipes, it is also copper, and then we can change the service according to what I want. So now the next thing is, can you see here we introduced a color to a particular, if in our generic systems we introduced a color to the different type of service according to our filter. So what I want is, I want my for example, I want my domestic cold water above ground to be of a particular color, so that at a glance I can be able to check the service of this particular system, domestic cold water above ground. So how do I do that? We go to VV, which is our visibility graphics, or VG. I'll simply go here, I'll simply VG it, and then I'll go to the filter option here. So none of the filters have been created. If I want to create a new filter, or if I can add the filters from this particular settings here, let us say I want to create a new filter, I'll go to edit, I'll simply create a new filter here, and I'll rename it as, let us say domestic cold water above ground filter, cold water above ground. I'll select OK, and then what I can do here is I can turn off the architecture structure. I'll simply mechanical, I'll simply select piping here, I'll select, and then I'll go here, I'll select MEP pipe work. Do we have some pipe accessories? Okay, pipe work here, and I'll select MEP pipe work here. I'll select fabrication pipes. Do we have some fabrication service? Do we have some fabrication service here? Yeah, fabrication service name, I'll select equal to, and I'll select the, no, where is the fabrication service name? Let me check it out, guys. If you want to create it on the base of work sets, you can create it on the base of work sets here. Can you see a work set option here, and then select that particular work set and change it to that. And but I want service, fabrication service, maybe, yeah, fabrication service, and I'll simply change it to domestic cold water plumbing, domestic cold water above ground. I'll select OK, and then I'll click OK, and now I add this particular filter. Where is this filter? I'm not able to see this filter. Yeah, here. Okay, I'll click OK, and then I can override the patterns, transparency, half tone, etc. I'll simply go overrides. I'll simply select this, since it's a cold water, I'll select blue and I'll click OK. If I want to change the pattern here, I can change the pattern. I'll click OK. I'll click OK. Okay, and now I want to create it. I can simply create it in the blue color. Can you see the blue color has been given to this? Okay, so by this we can create the different sort of services according to the colors and according to the drawings. So guys, let's take a look at some of the projects we have here. Let's take a look at this particular project here. Can you see here we have some plumbing legends here. We have the symbols for these water pipes. We have cold water pipes. It's really denoted in this particular drawing like this. We have a hot water pipe. We have a hot water return pipe, etc., etc. We have some valves here. Can you see we have shut off valve here. We have some butterfly valves. We have some check valves. All these legends you have to correlate between the drawings, and then we have some point of connection, etc., etc. And then can you see here, if a pipe is going down, it will be shown like this, like a half circle. If it's rising above the plane, it will be shown as a full circle here. We have some solenoid valve here as well. We have some circuits, etc., etc. We have some check valve here. We have some pumped storm, etc., etc. All these things you have to go through. And then we have some plumbing general notes. Go through these guys, and then we have some applicable codes. We have some California building codes since it's a US project. We have some other codes here as well. We have some PEX installation notes, unit summary, etc., etc. So guys go through all of these, and then on the next page we have some schedules. We have some plumbing schedule here as well. For example, WC1, wherever you see WC1, it will be a water closet in the units, and if it is in the public, it will be shown as WC2, and this will be the WV, etc., etc., hot water, cold water, etc., according to the services. Here is the manufacturer and the model. Here is the remarks here. And then for the lavatory, it will be denoted as L1. We have for the lavatory of public, it will be L2. And then some bathrooms, etc., etc., some kitchen sinks. We have some janitor closets. In janitor closets we have some MOP sinks as well. So some plumbing fixture schedules. We have some pump schedules here as well. We have some circulatory pump schedules here as well. We have some pipe material schedules here as well. Can you see the item and the material descriptions here as well? For example, for our cold water above ground, it will be L type copper and copper fittings with lead, etc., etc. You can go through all these. For the return water, reclaimed water, it will be crude fittings, etc., etc. You go through all of them, and then we have some pipe installations, insulation schedule. This is very important, guys. Every pipe will be given an insulation in the colder regions in order to prevent frost. So the temperature range is given here, some codes are given here, and then the installation schedule. For a nominal pipe diameter of less than 1 inches, it will be given an insulation of 1 inches, and for this particular range, this will given an insulation of 1.5 inches, and for this particular range, it will given an insulation of 2 inches. So here we have some air source schedule, swing tank schedule here as well, pumping and drain and clean out schedules. For in order to clear out all the blockages, we have some clean outs, and that's the clean out schedules are given here as well. We have some miscellaneous plumbing equipment schedules, etc., etc. Okay, we have some other schedules here as well. Go through all of them, and then on the next page we have our, can you see, level 1 plumbing plan in this particular project. This is the same project which we use for our mechanical HVAC units. Can you see here we place our HVAC units, I think in this page, in this location, FCU1 and FCU2 here, and this is our level 1 plumbing plan. And all of these plumbings will be done where? It will be done in the level 1 ceiling. Can you see, if we have a level 1 and then that level 1 has a ceiling, and all of these will be done in the level 1 ceiling plan, ceiling above ceiling, or level 2 below deck, right? And then this is the scope of area. Here we have to work, and here we have to work in the green areas. Here you have some general notes for this particular sheet. And then can you see here all the legends are used here? All the drawings are done by the legends. Can you see here for our hot water pipe, we have a tagging here. For this pipe, this is a long dash and then 3 short dashes. It shows it is a 3.5 inches 3.5 inches hot water reclaimed pipe, and then for 2 inches hot water pipe, this is the hot water pipe for 2 inches. And then we have some 2 inches cold water pipe. It has a long dash and a short dash, and then a long dash again. And then for reclaimed water, it is 1 and 1/4 inches. and sort of we have some valves here as well. This denotes the area of the flow, the direction of the flow, I mean. And then we have some stub ups here. Can you see it's a full circle? This means it's a stub up. And then some tags for these particular pipes. This means a tag. So this is a 3.5 inch irrigation sort of irrigation water pipe, and then for this pipe is 1 inch reclaimed water pipe. And then same for here, same here as well. You see here we have a stub down. Since it's a semicircle, it means stub down. We have some junctions here as well. You see this this pipe sort of goes and tees around to this pipe, and then we may have some reduction of the diameter here. We have some valves here as well. We have some stub ups here as well, and stub ups, stub downs here as well. And then the pipe comes from this particular area. So just focus on this green areas for now. And then the next thing, next page, we have level 2 plumbing plan. So can you see all the stub ups that were in level? Let me split the view here. Can you see in the previous page we had some stub ups here as well? Can you see it is between 3 and 2, 3 and 2.7 here. If we zoom into this 3 and 2, do we see? Can you see, guys? We have these stub ups. They're coming here. Can you see stub ups coming here? We have 1 2 3 4, 1 2 3 4, and then this one here, right? This one, I think, yeah, this one. We have some stub ups coming up here, and then on the other locations here as well. Let us check the other locations. Can you see here we have on the grid 3 we have stub downs. So let's check stub ups. Here we have stub ups. On the grid 2 we have some stub ups, 3 stub ups. Let's check them. On the grid 2 we have 3 stub ups. Yeah, exactly, we have some 3 stub ups, B/A. And then the other stub ups that we have here, this is actually an apartment plan. And then we have can you see how these stub ups are going, and then they're going here and then here as well, and then we'll have a manifold here as well. We'll see that manifold in the next enlarged plans. We'll simply move on to the next one, right? Close this one. We have some equipments here, pumping enlarged plans. Can you see we have some enlarged plans here? And then on the next page we have some sections, domestic hot water piping diagrams. We have some piping diagrams. Can you see we get power, we get our supply from here, and these sort of, we can see all the riser diagrams here. Can you see this is our level 2? So all the stub ups that we given here come on here, and then the flow of water is shown here. We'll learn how this thing actually works. We have some riser diagrams here as well. Can you see, guys? We have a stub up. This is going to apartment here, and then this manifold we can give we have a manifold here, and then this manifold gives flexible connections to all the equipments that we have in our washrooms. And then this is it. So let's learn how these drawings are executed on the plan, on the Revit itself. So one important thing that I forgot to tell you guys is this is all about the pressure pipes. This is all about the freshwater pipes. It has nothing to do, this particular assignment has nothing to do with our sanitary pipes or rainwater pipes. So in this particular drawing, all the things that you see is from our pressure pipes, and the scope of work is also for the pressure pipes. So now let's execute it. So guys, let's create these pipes. We have 5 pipes here. Can you see 1 2 3 4 5, and all of them have different service. So the first pipe is 1 inch. It is hot water return. So I'll simply go here and simply go to hot water return. Can you see hot water return above ground? Else simply it is 1 inches, and it is between it's just below C and between 3 and 3.4. So 3 and just 3 and 3.4 right there, and up to here, and I'll select this copper, and is it the size is 1 inch, so I'll just simply select 1 here. So 1 inch size here, I'll just make sure that the location is correct. I'll simply go here and place it here. And then the next one is next one we have is our, so 2.5 inches hot water. So I'll go here, hot water above ground, 2.5 inches. Okay, 2.5 inches. Do we have some 2.5 inches? We do. Simply do it and place it here. And then for the next one we have our 2-inch cold water. I'll go here, I'll go cold water above ground. Do we have some cold water above ground? Yeah, we have some. We'll select the pipe here and we'll select 2 inches here and we'll simply place it. And then the next one is our 1.5 inch reclaimed water. So I'll simply go here, I'll go to reclaimed water. Do we have some reclaimed water? Yeah, 2.5 inches. I'll select the copper pipe here, so it is 2.5 inches, right? I'll select 2.5 and simply put it here. And then the last one, so I think it was 1.5, so I'll just change it later. 3.5 inches irrigation water. So 3.5 inches irrigation. Do we have some irrigation? Yeah, above ground, 3.5 inches. I keep forgetting it is 3.5, so it's 3/4, right? Yeah, so I'll place it here and then I'll click escape. Now I'll change this to 1.5. So now I'll just give a dimension between them, di. So between this and this, and between this and this, and between this and this, and between this and this, right? So I'll give let us say 2 inches. You guys also have to factor in the insulation that we have according to the project itself. So I'll select this one, I'll select 3 inches, let's say 3 inches. Let's keep it at 3 inches. I'll select this one, 3 inches. So I'll select 3 inches here, 3 inches here, sorry, Control Z. This one I have to select and then select 3 inches, and then this one I'll select 3 inches. So now this looks alright. I'll just align them, AL, sorry, I have to align them with this. Okay, I'll just escape it now. I'll just take a detail line, DL, and then maybe I'll align it like this, and then AL, this one with this one, this one, sorry, AL, this one with this one, this one with this one, and this one. Simply delete them, go here. So now my 4 pipes have been placed. Can you see we also have a takeoff from these particular pipes here? So this pipe, the last one, that is the 3/4 inch irrigation pipe, simply bends to the left, and then we have the takeoff from these particular pipes. Now how do we model these takeoffs? So the closest pipe should be done first. So first of all, let me take a 90-degree bend here, 3.5 irrigation. Can you see 3.5 irrigation right here? So I'll go to my Revit again. I'll simply check the location at which I have to give this. So it has to be on the 3. Okay, I'll go back to my Revit. So it is here. Maybe I have to move them to this side. Let it be here. Okay, so I'll just go here and then I'll just take it here, and then what I'm going to be doing, I'm going to be taking this 90-degree elbow, and then I'm going to be placing it here. Before that, I've not checked any elevation. So what I'm going to be checking an elevation here, I'm going to be taking a section here. Can you see a section? I've placed a section here. I'll simply go to the view now, and if I zoom in, can you see these have been, this is the ceiling. I'll just move it a little bit upwards. Now looks alright. Go back to my level 1, and then let's go to this part here, and then can you see the service here? If I click on this and go back, it is an irrigation plumbing, irrigation AG. Let us say that okay, let's first of all place this, simply place this like this and then like this. Okay, it has been placed correctly, and I'll go back here. Okay, and then I have to take this off from these particular pipes. So what I can do here is simply move this service point, and then I'll place a T here. Can you see we have a T here? I'll place a T pointing upwards. I'll use this insert button here, and I'll press space to move it upwards. Can you see this? Can you see the service does not match because I have selected irrigation pipe here, and the second pipe is we have a reclaimed water pipe here. So if I continue this, it will automatically change its service. Can you see the service has now been changed? Let us move it upwards. 45 degree, 45 degree, 45 degree, 45 degree. Okay, now it has been moved upwards, right? Looks alright. And then I'll just place a pipe. So every time I have to change the service here. So in order to not do this every time, what I can do it, I'll select this pipe, I'll press CS, which is create similar. Can you see now the service has been changed here? Simply this pipe, and then place it here. Okay, I placed it here, and then I'll simply press click on this CS create similar, and then I'll just go for a T here. I'll place this T upwards. So blue means up. I can simply place it here as well. Okay, and then here as well. Continue. Okay, so this is wrong. This has been placed wrong. Okay, now these have been placed correctly. Simply do this. Simply, maybe I have to do this like this. CS create similar, and then let us place a stub up here, and then I'll escape it, select this one CS. Can you see the change? It changes, and then I'll press this one, continue, and then this one CS. Then now let's select it, and now let's place it. Yeah, let's view this particular section now. Can you see they have correctly stubbed up? So guys, up until now we have learned about pressure pipes that are also called the potable water pipes. So these pipes, we have learned how to model them, how do we connect them to the main water pipes, and then how they are distributed throughout a building and connected to different fixtures, and we have learned how do we read the riser diagrams, etc., and how all the modeling works for pressure pipes. Now a very important detail here is that they are the pressure pipes. So that means that the water in these pipes are pressured. So that means in turn that they don't need to be assisted by the gravity itself. Now the part second and the part third of the plumbing is our DWV pipes and our stormwater drainage pipes. So DWV pipes, as you guys know, are the drains. Can you see here we have a fixture here, we have a wash basin sort of a thing. The water from this will get drained, and those pipes will be called as drain pipes. We have waste pipes. Can you see a water closet or a toilet seat here? Can you see all the waste from this particular toilet seat will be going through these pipes called as waste pipes. And then in order to prevent or in order to sort of excel and remove all the bad nuisances and the bad smells, we have a pipe here. Can you see we have a riser here? These pipes are called as vent pipes. So D drain, W means vent, waste, and then V means vent pipe, DWV pipes. We also have some of the pipes for our stormwater drainage management. Those pipes are called as stormwater pipes. Okay, so now let us take a look at a sample project in which we're going to be learning how to model and how to learn how to read all these diagrams that are presented to us by the design engineers, right? So let us take a look at a similar project here that I have now. So this is the project. We're going to be quickly breezing through these pages. We have our plumbing legends, we have our general notes. These plumbing legends are important because all the design drawings will be done in these particular symbols and abbreviations and the descriptions here. For example, if we have a straight pipe, this means that this will be an SS pipe. What does SS pipe mean? It means that sanitary sewer pipe or a waste pipe. Similarly, if we see this particular symbol here, this means that we have a storm drainage pipe. If we see this pipe, sort of a dash pipe here, we'll add a V next to it. It means that it will be a vent pipe. Similarly, if we have a sort of a semicircle here. This means that the pipe is going down or it is tubbing down. If we have a full circle here, this means that the pipe is rising above the above a particular floor, right? And then we have this particular sort of a BMW symbol here called point of connection. It is the point at which our plumbing system gets linked to the municipality drainage system or connection system, right? So we have to go through all these legends, and we'll be zooming through the next pages. We have our schedules here. We have our, can you see, level 1 plumbing plan, which is the underground. This is our underground plan. We can see in our underground plan, we can see our point of connection here. Can you see we have a point of connection here, and then the details about this point of connection. For example, we have our IE, that means that invert elevation. It means the elevation at which the water is actually flowing. Can you see we have a pipe here? This is a cross section of this particular pipe, and this pipe will have a certain thickness. The outside elevation for this particular pipe is known as the outside elevation, and the elevation at which the water inside the pipe actually flows is known as the invert elevation. And we have some details about this point of connection. We have, this is that 8-inch sanitary sewer pipe, which are with a slope of 1/4 inches per square feet, right? Per running feet, right? So this, we have to model this yellow area here. This is our underground plan. The next we have is our level 1 plan. We have to model this particular area. Actually, we have to model all the things, but for this particular masterclass, we're going to be learning only modeling for this particular area. This is our level 1 plan. It includes storm water, waste and vent pipe. And then we have our level 2 plumbing plan. In this particular sort of a plan, will be given the detail about the risers. We'll know what the risers are. Can you see here? We have one riser, 2 riser, 3 riser. These are tags for these particular risers. Can you see the pointer here? We will be seeing about these risers using these tags. The next page we have is our level 3 plumbing plan, and our level 4 plumbing plan, level 5 maybe level roof plan, yeah. And then we have enlarged plans, and now we have a riser plans. Can you see? Hi guys, there was a B. So this is called a riser diagram. So what this diagram denotes is that it correlates. For example, we have just seen the floor plans, but floor plan doesn't give all the details about how the different systems between the different floors are actually interconnected with different with each other, right? So we have a floor 1, we have a floor 2, we have a floor 3, we have a floor 4, we have a floor 5, and how they are connected in the vertical orientation, how the stub ups and stub downs get connected with each other. All the details are given by these diagrams known as riser diagrams. Okay, we'll move on to the next page. We have some other riser diagrams here. We have some details, and that's it. Let us start. So guys, let's execute these drawings into our project. So we'll be starting with our underground floor plan. In this underground floor plan, we are given some general instructions. So for our sanitary pipes, that are our waste pipes, we have a slope of 1/4 inches, and then for our storm water drainage pipes, we have a slope of 1/8 inches. So also we are given some of the highlighted pipes here. So in this particular masterclass, we are going to be only modeling these highlighted pipes here. Also, we are given a point of connection. So what is this point of connection? It is a point at which the drainage system, the wastewater system, and the sanitary waste system all gets connected to the sewage system provided by a locality or our municipality, right? So in this particular point of contact, we have some details here. We are given IE. What this IE means? It means inverted elevation. So if we have, let us learn. Let me take a circle here. So let us say this is our pipe, and in this particular pipe may have some thickness. Let us say it may have some thickness like this. It may have a thickness of this much. So when it is filled with water, it has two sort of elevations. This is our outer elevation, and this elevation the water actually flows in is called at inverted elevation. So this is all about inverted elevation. Now let's start modeling these pipes from this particular elevation. We have our grid is B, and the other grid is 7. So I'll go back to my Revit now. So I start modeling this. I'll just do one thing is I'll just remove this for now, and then I'll be since we're dealing with underground sanitary pipes, I'll be selecting this plumbing, sanitary and waste, and then BG, right? BG means below ground. So we have a PVC pipe here. So as we know, every time we use plumbing in our below ground, we use a PVC pipe, right? So I'll select this PVC pipe, and then can you see, guys, I'll be just turn off the smart snapping, and I'll just turn on the slope. Since we're moving outside to inside, so will be the slope should be up, and then I'll be giving the value to this particular slope according to the general specifications. It is 1/4 inches, right? I'll be selecting this, and I can now toggle this particular pipe here. Can you see, if I press space, I'm able to toggle this. So let us start modeling this. I'll just give a lower elevation for now. I'll just give a lower elevation of, let us say, -4 feet. -4 feet. I have given an elevation of -4 feet. I've applied it. So let us place this pipe here for now. Okay, now since I'm not able to see the slope of this particular pipe, what I can do is I can take the section here, and let us apply a section here, and I'll just go to the section. I'll just go to the view now. Can you see, I'm able to select this pipe, but also we have to check what sort of a pipe we have. So it is 8 inches wastewater pipe, right? But I think I don't have this particular 8 inch. Do we have some 8 inch? No. Yeah, we have some 8 inch, but I don't think we have these. Do we have some 8 inch? No, the maximum size that we have is of our 6 inches. So we'll be modeling 6 inches pipes. So I'll select this. I'll just turn the size to 6 inches, and I'll apply it now. Now the next thing that we have, I'll just turn off the levels now. Okay, then levels have been turned off, and I will just increase the detail level, and let's keep it shaded. Now the next thing that we have to take care of is we have our inverted elevation of 52.2 feet. So this means our first floor where is our first floor? I'll just turn on the levels again, or I'll simply do Control Z. So can you see, guys, our first floor is at 60 feet. So this means I'll just turn on Control White again. So this means if I take a pen here, so this means 60. We have 60 feet, and then we'll just minus the invert elevation here called 52.2. Just 52.2 feet. So we get what we get? We get 7 feet 9 inches, right? So 7 feet 9 inches we have to select here. I'll just go back to my Revit. I'll just take a detail line DL. I'll simply place this line for now, and then I'll just go back, and I'll just select DI, that is my dimensions. I'll just select this and this, and now let me check. I'll just turn on the levels. L, I have to check whether I placed the dimensions correctly. Yeah, looks like I've done it correctly. And then I'll just select this particular detail line. I'll just type 7 feet 9 inches, right? Okay, so now I'll just AL for align. I'll simply select I have to AL again, select this and select this. So now this has been placed at a proper orientation, right? So I'll just delete this for now. What I can do here is I can go to my underground plan now, and let us see asset, which is create similar. Make sure the slope is always selected, and I'll just turn on this smart snacking here, and then I'll start modeling it. And then I think it is moving in this particular direction. Now we have a sort of a double Y here. Sorry, I'll just go back to my Revit, and I'll click on this double Y, and then I'll select the correct size and then place it here. I'll select CS, which is create similar. I'll simply extend I simply extend it on both sides and on this particular side as well, and I'll just SL, which is slice, SL it from this particular side. I'll check my, so it is going up here, it is going up here as well. It is 4 inches, it is 6 inches, right? So I'll just go here. I think it is stubbing up a little bit here. I'll just check the orientation a little bit later. I'll just show you guys how we model this particular thing now. This is 6 inches, right? So do we have some 6 inches 4 into, so I don't have that particular family, so you guys can get that family and apply the correct sort of size here, right? So I'll just go for this long sweep here. I'll select this, I'll toggle this so that blue sort of arrow shows. This means that it is toggling up. I'll simply escape it for now. I'll SL it and then I'll just select this again, select this. Now I'll simply stub it up using these particular pipes here, and then can you see I'm not able to fully see this pipe. Can you see this sort of thing is blocking my pipe? So what I can do for that is I'll go to VV, so visibility graphics, go to Revit links, I'll just underlay it. I'll click OK. Can you see now it shows? So I'll simply press on this pipe and just extend this. To which does it extend? It extends to C. So I have, where is C? So it extends up to here, I think. So I'll SL it right here. I'll just delete this, get some I think in this particular direction, and then I'll simply drag this one, and I'll just check it again. So up to 3, so I'll just drag it up to 3, and then it is, I think, going down again. Now we have some double Y here again, and it's going down into this particular pillar here, into this particular column here. So I'll just go and select this particular double Y. I'm not taking care of the dimension, guys. I'll just leave it to you, because it will take a lot of time if I go step by step from here, right? Just take an elbow here, and I'll take a pipe here as well, and then from here yeah, we have, this is 4-inch wastewater pipe, and then this is stubbing up. So I'll just stub it up here, SL it quickly, and then I'll just delete this and then stub it up here like this, and then select this pipe, and then I'll just stub it up now. So I'll just take another section, or else I can simply move this particular section from this base point to this, right? Okay, I'll select OK. Now I'm able to see this. I'll just go to this particular view now. Can you see how we have a stub up here? But this is a PVC pipe, so in our above ground we don't use our PVC pipe. So I'll just SL it. So I'll just cut it here, and I'll apply. I'll change the change it to above ground, sanitary plumbing, sanitary above ground. Can we see we have our cast iron pipes now? So I have a fitting here that allows the conversion. So I'll just select 4. Do we have some 4 into 4? 4 into 4. Like this. So I'll just continue it for now. So I'll select this now, this particular pipe, and go for 4 inches here, and then I'll select 4 inches here, and I'll simply go back here. I think it is not getting toggle snap, so what I can do is I'll just delete this, and I'll just add it back a little bit later. Switch service, right? No, control Z it. I'll simply go here and select the above ground again, and take this pipe. I'll just delete this, take this pipe now. I'll just continue placing this. For now I'll just delete this and then edit this one in. I'll just do this insert part, and then let's place it like this. Okay, so now it has been placed correctly. If I select this, can you see we have a cast iron pipe, and for this we have a PVC pipe, right? So it is stubbing up. So I think my underground modeling is complete. So guys, we have completed all the modeling that we had to do on our underground floor, labeled as level 1 pumping plan on the underground. Now we modeled all this, but where did we model it, and where was these drawings executed? Let us learn a little bit more about this. If I go to my Revit now, and if I go to the underground page, can you see if I extend this, and if I extend the sort of range of this particular section here, and now I see the section 2. Can you see, guys, all of these drawings were executed below my foundation. So this is my foundation, right? So this is my foundation. So all of this was executed under my foundation, so into this soil. So all of this is soil, right? Under this foundation we have soil, we have mud, we have some sort of rocks. So all of these drawings that we saw in this particular plan was executed below the deck, right, below the foundation. Now if we move on to the next page, can you see we have a new drawing labeled level 1 plumbing plan, storm, waste and vent, and we have a highlighted section here. So now where will this be executed in our Revit? So this is very important, guys. Take very good attention of this. So if I go to my Revit, so this particular plan will always be executed below the deck of the first floor. So this is first floor, these are some parking areas, and we have the slab of this first floor, and all these drawings that we see on this page will be executed below this deck, right, below the slab of this particular first floor slab, right? But if we go to the drawing here, and if I take a split view here, can you see, if I move on to the previous page here, under the near the grid 2.7 we have a stub up near to this particular column, right? If I take the pen here, can you see a column here and a stub up here that we just modeled? This has now been placed near to this grid 2.7. Now if I see the next plan that we have near to this grid 2.7, we have located this column. Can you see a column here? But now here we have two stub ups. Can you see one stub up and the two stub up, right? So why do we have these particular two stub ups here, and here we have only one stub up? How can this happen? So I'll tell you how this happens. Let's simply just move on to the Revit and go to the underground plan. Can you see, guys, we have selected the right, so we have done this all this in the underground floor. Now how do we create sort of two stubs up from one stub up? I'll show you why. So we use a fitting here called Y. So sort of this combination. Can you see here a combination? We'll select this. This upright Y. Can you see a fitting here called upright Y? I'll select this fitting. Now this is very important, guys. Can you see, if we are to sort of model these particular two stubs up here, how do we model this? So this is our column. Can we see our column in our Revit? Yeah, we can see this column. So this sort of stub up is onto the lower side of this column when viewed in the underground floor, right? So this column, on the bottom side of this column we have this stub up, right? If I move to this, on the bottom side we have this stub up, right? How do I create create a Y, upright Y, in such a way that two stub ups gets created? So I'll go back to my Revit. I'll use this Y, upright Y. I'll select the correct size here. I'll select 4x3, Y 4x3. If I go back to my view, can you see we have a 3 inch, and then we have a 4-inch sort of pipe here, right? So then the 3-inch should be on the right. So we'll just take care of that later. Simply go here, select this upright Y, and we'll try to place it in this particular I have taken a section here. So this is the section 2. I'll simply jump into this section and I'll simply try to place it. So I'll just simply turn off the smart snapping and insert this, like maybe I'll just have to toggle connect it this way, and now I'll place it like this. Let us see if it is in the correct orientation. If I go to my underground plan, I'm not able to see it, but I'm able to see this in my level 1. So this is not the correct orientation, right? Because we want it like this. On 3 should be on the bottom side, and then the 4 should be on the top side. So I'll just go back here. I'll simply select on this and just turn it in the other direction like this. And now I can go back to my section. I go back to my other section that is on the 90 degree. I'll simply go here. I'll simply take this pipe now. I'll just place this pipe here and just place this pipe here as well. I'll isolate here and here. I'll just delete these sections here. I'll take a short sweep. I'll place it like this and place it the other one opposite, and I'll just take a pipe here and have some pipes here like this, and then I'll just view it in my level 1 So this is not correct, guys. It is still not correct. So what I can do is I'll simply delete this. I'll just turn it here like this, like this. Sorry, Control Z it. Simply select it. I'll simply select it, turn it this the other way, Now it has been turned in the proper orientation. I'll simply select this, turn it this way, and then this way again. Now can you see on the bottom side of this column we have just place the pipe first. On the bottom side of this column we have a 4-inch pipe going the left way. Can you see 4-inch here, and the 3-inch pipe going the right way. If we check this in this particular drawing, we have a 4-inch pipe on the left side and the 3-inch pipe on the right side, right? So this is correct. Now let me try to create all these things. I'll just simply close this for now and try to create this one. We have a 3-inch pipe that has been going. We have some void connection here, we have void connection here as well, and then we have, so I'll just try to create it. So guys, what I've done is I've modeled this particular drawing. Can you see this particular drawing that is highlighted here in the yellow in the level 1 plumbing plan? So I've tried to model this as closely as I can using this these sort of dimensions and these sort of layout here only. So I've modeled it here, but it doesn't tell me anything. So what does this tell me? Where I know where this drawing is if I go to this section, and then so this is my underground plan. So I've modeled this underground plan, and then this is my foundation. So this pipe goes up to the foundation and then into this ceiling and below the level below the first floor slab. All of this you can see here is modeled below the first floor slab. Now what is the utility of this? I'll tell you guys the utility of this. Can you see here? Each sort of pipe has a connection that has to be given to a particular water closet. Can you see here? We are able to see a water closet here. We have some drains here. We have some sinks here. So we'll be giving these connections to these particular sinks and drains, etc., etc. How do we understand those connections? We're going to be understanding those connections using these drawings here. If I go here, this is my level 1 plan, which is basically my let me have some. This is basically my below first floor slab in first floor area, right? So all this is nothing but it is in the below the first floor slab and it is in the ceiling area of the first floor, right? So if I move on to the next page now, where is this plan? So this plan is in the second floor. Can you see? This is all in the second floor. And then let us correlate between these two. I'll just take a split view here and go to the back. I'll just go to the previous page on this, or let's go to the previous page on this particular and then the forward on this one, right? Right, so I'll just select this area. Can you see in this particular area? So near grid 3, we'll just move on to the near grid 3, right? Grid 3, this is the grid 3, and move on to this area. We have some stub ups here. Can you see stub up, and some of them have been labeled as wastewater. The W starts for sanitary pipes, and then the V stands for our vent pipes. So let's look a little bit closely to this. We have a water closet or toilet. It has a drain, so we can directly correlate. We have a separate drain here. So this particular drain, I'll just use this marker here. I'll just rename it as 1. So 1. So this particular sort of stub up goes into this sort of a lavatory, or you can say a toilet seat. So I'll just rename it as 1 here. 1 correlates with 1, and then we have the vent of this this sort of a lavatory has also a vent pipe. So this particular vent pipe, can you see here? So this is 2. So we have our 2 here, and then can you see this is vent, 2-inch vent pipe, and then we have, can you see a sink here? Can you see we have a sink here? Do we have sink here? Yeah. So this sort of a stub up goes into this the drain of this sink. So I'll just rename it as 3. So this is 3, and then this sort of sink also has a vent. Can you see this also has a vent here? And then we have our 4. This is the sink of this particular the other unit here. Can you see we have a sink here and we have a sink here as well. The 3 sink correlates with this particular sink. The 4 sink will correlate with this particular sink. So this is 4, and then we move on here. Can you see here, guys? We have a sort of a bathtub here. So this is the bathtub. This is the 5. So this bathtub will have a drain called 5. So it will also have a vent. Can you see we have a vent pipe here as well? We have a vent pipe here. It's also denoted as 2-inch W, right? So this is 6. So this has to be correlated with this 6. Can you see we have 6 stub ups, and then this ultimately goes, and this all has a sort of a 2-inch waste pipe here. So this all comes into a 2-inch waste pipe which goes up, right? So we have our stub up here which goes outside. This is outside, and then let's rename it as 7, and this stub up is 7 here. Can you see? Now guys, let's try to align this. Since we have correlated these drawings with these this level which is the below slab and this level which is the above slab, we have correlated between them. Now let's try to align this. I'll just close this one, and can you see here I will try to align this particular one with the water closet. I'll simply go here. I'll simply go to the level 2. Here we have the stub up for this, and now I'm not able to see the whole of the pipe. So what I can do is I can go to VV, I can go to Revit links, I can simply change the underlay option here. I'm still not able to see it because I have to change the wave range. I'll go to wave range. I'll just give an offset here of -7. 7 feet, and here as well -7 feet. And now I'll be able to see those particular pipes in entirety. I'll simply move this particular sort of, let us see if I can move it in such a way. So this has not been connected properly, so I'll just align it first. AL align. So I'll just align it, this one with this one, and then let us try to connect them. Yeah, they have been connected. Can you see? If I tab on this, now the entire thing gets selected, right? Looks alright. And then what I can do is I can go back to my and I'll try to align this particular with the water closet here. I think okay, let us leave it at that, and I'll just cancel it for now. And then the next thing that we have is I'll just try to align the drain. We have a drain of this, and then it has a vent pipe, right? Yes, it has a vent pipe as well. So I'll just try go over here, and I'll try to align this drain. I'll just go here, just move them down, I'll just try to align this drain. Just take a split view in order to see the previous drawing here as well, right? I'll just go here, and now we have the vent from this, which is going upwards, okay, and then from drain from this, okay. So I'll just go here. So this is the vent pipe, right? So what I'll do is I'll just try to align this with the middle of the sink here, and then I'll try to move it into the wall, because this will go all into the wall. And then for this we have the sink in the other room. I'll try to, so I won't be able to get too close. Simply select it and go across up until here. I'll just move it a little bit up, and then this one, okay. So now what I can do here is I'll have to align this one, okay. What I can do is I can go to the section here, I'll create a section here. I'm not able to see the sections. Go to VV, I'll just click S section, section boxes, sections, okay. So I'm able to see the section now. I'll just delete this for now. Just select this section. I'll just move it very close to these two pipes, and then go to the view, and then VV it, close the levels and level rings. Just do it just like this, okay, like this. Maybe let us widen it a little bit, and then let's go to the section, okay. So now what I want here is, now guys, can you see here we have a sort of two pipes that I have made, these two pipes, and then the third pipe we have is our vent pipe. So this comes, the vent comes from this water closet that we have. Can we see here water closet? This has a separate pipe. This has this pipe, and it has a vent out, and this vent out sort of comes out like this, and then can you see we have this connection here. So this is the one, and then from this a pipe arises, and then it goes here. Can you see? Control Z it, Control Z. Just make it once again. Sort of comes, a pipe comes from here. This is a vent pipe, and then goes here in this second wall, right? So I'll try to recreate this. Simply go to building. I've already created this pipe, right? So I just move this pipe to the wall, into the wall, right? And then if I go to the section, I'm able to see the three things now. Now before doing that, I have to give the connection of these particular kitchen sinks. I'll slice it here. I'll just Control Z it, Control Z it again, escape it, and then here I'll just go to Y here, and then what I can do here is what is the just use the toggle connector here. Yeah, like this, and then here as well. And use the toggle connector here as well. So I've used the wrong one here. Simply CS it, and then I want it the other way. I'll just use the toggle connector. Yeah, like this, and then what I can do here is add a P-trap. So I'll just add a little bit of pipe first, like this, and then SL it here, SL it here, and then select this, delete this, select this, delete this, and then use the P-trap here. So I'm not able to toggle connect test. So do we have some other P-traps? So let's use this one. And now let's use the toggle connector now and paste it here, and the same way let me just toggle connect it. Exactly, now this has been done. So I'll just try to make it go inside, and then this as well. So I can simply take the drain from here and then go a little bit down, maybe bring it here a little bit, and then the drain from these water closets, these sinks, and this sink will get collected into this, and then we have to go to this one, and then we have to change this because the vent pipe elevation should be always above the waste pipe. So I'll select this, I'll go to simply go here, tab it, and P exit, which is box. I'll simply go again here, and let us look at it in 3D. I'll just expand this a little bit, expand this. So this is our vent pipe. I'll make sure I'll just remove this for now, and then let me view it in another angle. I'll simply do this. I'll simply remove this as well and remove this as well, and then let me delete this and let me rotate it a little bit. I'll just rotate it 45 degrees, right? I'll just go here and I'll just pick this pipe here and then a little higher, and then I'll simply SL it here, and then I will take a 8th bend. Let me see the orientation here. Okay, so I'll just take a quarter bend here, or let's do it in this, like this. Is it okay? Looks alright. And let us give it a little bit of room to work with. No, this is getting this one. So like this, and then what I want is I want some pipe here, and then I'll SL it. I'll just use this one, 8th bend now, or perhaps the 16th bend. Will it work? So I'll just go delete this one, and then maybe we'll use Okay, Control C it for now. So what I'll do here is I will just align this ASL. Now I'll just try to split this here and move this exactly to the right, and then I'll match it. I'll align the middle elevation of this with this has been aligned, and then what I'll try to do here is, so this is 16th bend, right? So this won't work. Maybe the 8th bend, no. So for now I'll just use this 8th bend here, or the 16th bend maybe. I'll just try to align this with this. Doesn't happen. Simply like this, and maybe I'll have to match the elevation as well. AL, simply try to match the elevation of this with this. Now the elevation has matched, so the vent sort of works now. And the next thing that we have is, are we able to see this? So let me check this out if this works. So I'll just extend it a little bit for my water closet and my drain, sink, etc, etc. So this is my sink. I'll just VV it and give it a little bit of tone here. Can you see, guys? This is my sink, and this is my kitchen sink, this is my closet, and this is my witcher sink, and we'll have a sort of a toilet seat here, and then this is venting up. So this sort of pipe is going up, and if I go here, if I go to the section now, I'll be able to move them up here. I'll just use this here as well and here as well, just move them up, and then this, it is complete here. The next thing that we have is our riser diagrams, and we'll be seeing that riser diagrams here. How do we apply it here?